Hi, welcome all. This is R. Selvakumar from 6 Engineering. In this video, we are going to see types of foundations. This video is lengthy video, so please do not skip in between. Please watch the entire video. Please subscribe and press bell icon for further notifications. Okay, let us begin. What is foundation? Foundation is the bottommost part of the building or the civil structure that is in direct contact with the soil, which is transfers loads from the superstructure to the soil safely. Types of foundation. The foundations are grouped into two broad categories. First one is shallow foundation, second one is deep foundations. Let us see what is shallow foundation. If df is less than or equal to wf, then the foundation is shallow foundation. If df is greater than wf, then the foundation is deep foundation, where df equal to depth of foundation and wf is width of foundation. Types of shallow foundations. Shallow foundations shall be grouped into two categories. First one is footings, second one is raft or mats. The footings can be classified as spread footing, strap or cantilever footing and combined footing. The spread footing further classified as continuous or strip or wall footing and isolated or individual footing. The individual footing may be square or circular or rectangular. The combined footing is further classified into two groups. First one is rectangular and second one is trapezoidal. Types of deep foundations. The deep foundation shall be classified into four groups. First one is deep footings or continuous or isolated footings. Second one is piles. Third one is piers. Fourth one is caissons or wells. Spread footings. The spread footing is a pad type arrangement used to spread the loads from column or wall to the large area of foundation soil. Spread footings are constructed as close to the ground surface. Yes, spread footings need not necessarily be at small depths. It may be located deep in the ground if the soil conditions or the design criteria require. If spread footing supports wall, then it is called as continuous or wall or strip footing. If spread footing supports a column, then it is called as individual or an isolated footing. In these figures, we can see continuous or wall or strip footing. In the left hand side picture, we can see concrete footing supports the brick foundation wall. The right hand side picture we can see the continuous wall footing which supports foundation wall, in which the continuous wall footing is made up of concrete. The foundation wall also made up of concrete. In the left hand side we can see the continuous or strip or wall footing and the middle image shows the footing with the stepped foundation wall, and right hand side photograph shows the continuous or wall or strip footing made up of concrete over which uh, we can build the foundation wall, which may be stepped or a single wall as in left hand side image. Isolated footing. Isolated footing can be classified into three categories. First one is square footings, and second one is circle in plan, and third one is rectangular footings. It will be rectangular in plan. The isolated footing can be further classified as pad footing or stepped footing or sloped footing. The first one is pad footing. The middle image shows the stepped footing, and right side image shows sloped footing. The photograph in left side shows the sloped footing, and the middle photograph shows stepped footing, and the right side shows isolated square footing. Monolithic footings. Monolithic footings are used for watertight basements. It is also used for resisting uplift. Village foundations. Village foundations are used for heavy loads. We can see in the figure the column is there, below that base plate is there. Below the base plate or iron plate we can see steel beams or grill ledge are arranged to distribute the load to the larger area. Below the steel beams we can see the another base plate or bottom plate. The bottom plate is sitting on the concrete pad, so the concrete pad will distribute the load to the soil. Strap footings. It comprises two or more footings connected by a beam called strap. This is also called a cantilever footing. This may be required when the footings of an exterior column cannot extend into an adjoining property. Different type of strap footings in this figure given below. The difference are the thickness of strap or beam, the levels of footing, and the levels of strap beams. Combined footings. A combined footing supports two or more columns in a row when areas required for individual footings are overlapping or they come very near each other. They are also preferred in situations of limited space on one side owing to existence of the boundary line of private property. In a plan, it may be rectangular or trapezoidal in shape. In the figure given here we can see the rectangular combined footings and the trapezoidal combined footing. In the left hand side photograph we can see combined footing with two columns. It is rectangular in plan, and in the right hand side photograph we can see rectangular combined footing with two columns. It is stepped footing. Raft or mat foundation. A raft or mat foundation is a large footing, usually supporting walls as well as several columns in two or more rows. This is adopted when individual column footings would tend to be too close or tend to overlap. This is considered suitable when different settlements are rising out of footing on a weak soil or to be minimized. We can see the raft or mat foundation in the figure given here. The top one is section and the bottom one is plan. In this raft or mat foundation, both wall and columns are present. Near to the edges, we can see the walls are constructed. In the inner bay, we can see the columns are constructed. Without wall also, we can do we can construct the raft foundation. Deep footings. If the depth is more than the breadth, the footings are considered as a deep footings. Meyerhoff developed the theory of bearing capacity for such footings. Let us see deep foundations. This is a foundation generally in the form of piles, caissons, diaphragm walls, used separately or in combination to transmit the loads to a deeper load bearing strata when no adequate bearing strata exist at shallow depths. The transference of loads by a deep foundation may be through friction or end bearing or combination of both. The various type of deep foundations are pile foundations. The pile foundations are further classified as driven cast in situ piles, board cast in situ pile, driven precast, board precast, timber, under reamed piles. The other type of deep foundations are caissons, diaphragm walls, well foundations. In this figure, we can see the piles are subjected to the external load or the load from the structure. The external loads are resisted by the two components of the pile. One is side friction, another one is end bearing. In this figure we can see the external load is QU and this QU, the external load, will be resisted by the two components. One is QS, another one is QP. The total resistance is QP plus QS. This is the total resistance. The total resistance should be greater than or equal to QU. In this figure we can see the group of piles are supporting the superstructure. In this particular case, we will have 3 layers of soil, but in the number of layers will vary according to the site conditions. It may be more than this or it may be less than this. Pier foundation. It is somewhat similar to pile foundations. Its cross-sectional area is larger than piles. An opening is drilled to the desired depth and concrete is poured to make a pier foundation. These foundations are mostly used for bridge foundations. The figure given below shows the pier foundation. Caissons or well foundation. A caisson is a structural box or a chamber that is sunk into place or built in place by systematic excavation below the bottom. Caissons are constructed in such a way that the water can be pumped out, keeping the work environment dry. Types of caissons. First one is open caisson, second pneumatic caisson, third is box caisson, fourth is floating caisson. The first figure shows pile type open caisson, which is circular in plan, and second one is box type open caisson. We can see number of 6 number of compartments are there for this caisson, and this figure C shows pneumatic caisson, and figure D shows box or floating caisson. Okay. The photographs shows box type caissons, and the photograph on the right side shows pile type open caissons. Diaphragm walls. A diaphragm wall is a structural concrete wall constructed in a deep trench excavation, either cast in situ or using precast concrete components. Diaphragm walls are often used on congested sites close to existing structures where there is restricted headroom, or where the excavation is of a depth that would otherwise require the removal of much greater volume of soil to provide stable battered slopes. Here we can see the diaphragm wall constructed near to the existing structure, and in the another side the new construction is going on. The figure on the right side shows the diaphragm as a foundation, diaphragm wall as a foundation. Okay, this is the berthing structure. It will be the berthing structures will be constructed in the ports and harbors, and this is the diaphragm wall. This is the diaphragm wall, and it is supporting beams, and these are all the beams. This is also a beam, and this is also a beam. Okay, and over which the slab is laid, and this one is pile. This one is pile. This one is pile, and this one is also a diaphragm wall. Generally we will call it as an anchor wall. Okay, here in this figure we can see these diaphragm walls are not taking any vertical loads, but it is subjected to a horizontal load, that means lateral loads, but in this structure we can see the diaphragm walls are subjected to lateral load as well as the vertical loads. Okay, so this will be act as a foundation. Okay, floating foundation. It is a special type of foundation construction useful in locations where deep deposits of compressible cohesive soil exist and the use of pile is impractical. The concept of floating foundation requires that the substructure be assembled as a combination of raft and caisson to create a rigid box. This foundation is installed at such a depth that the total weight of the soil excavated for the rigid box equals the total weight of the planned structure. Theoretically speaking, therefore, the soil below the structure is not subjected to any increase in stress. Consequently, no settlement is to be expected. However, some settlement does occur, usually because the soil at the bottom of the excavation expands after excavation and gets recompressed during and after construction. The figure given here shows the floating foundation. Okay, see the weight of excavated soil. This is the excavated soil from here. Okay, this portion is the excavated portion. Okay, the weight of the excavated soil should be equal to the weight of building. So the weight of building should be equal to the weight of the excavated soil. Okay, foundations for special structures. Foundations for certain structures and or machineries require special design and detailing procedure taking into consideration the impact and vibration characteristics of the load and the soil properties under dynamic conditions, and may have combination of foundation structure. The various type of such foundations are reciprocating type, impact type, rotary type. In rotary type we can have medium and high frequency, and rotary type low frequency, impact type. Figure given below shows the machine foundation. Tower foundations. In tower foundations we have transmission line towers and poles, and radar antenna, microwave and TV towers. Apart from the foundations given in this video, we have stone masonry foundations, but I did not give in this video, but I am going to publish one more video for that kind of foundations. Thanks for watching. Do not forget to subscribe, share and like. Thanks for watching.